Hello viewers, welcome to Learn Compute Tech Easy channel. In this video, we are going to discuss about product of max terms. Product of max terms means it is product of R terms where each R term should have all the variables in the boolean expression. That is the given boolean expression. To convert a boolean expression into product of max terms, first of all, the boolean expression should be in product of R terms. So, in this given boolean function, we should not have this boolean expression in the form of product of R terms. To convert this boolean expression into product of R terms, we are going to apply distributive law to this expression. Let xy be A, x dash be B, Z be C, A plus BC. If you apply distributive law to this boolean function, it becomes A plus B into A plus C. Here A is xy plus B is x dash. So x dash. Xy plus x dash into A plus C. Xy plus Z. Again, we apply distributive law to this term or term. It becomes x plus x dash into x dash plus y. Again, we apply distributive law to this term. It becomes x plus z into y plus z. Okay, x plus x dash becomes 1. We can write these terms, the remaining terms, x dash plus y into x plus z into y plus z. Now, this boolean function becomes the product of R terms. If we want to convert this boolean expression into product of max terms, we should include for each R term the missing term. We should include the missing term for each R term. Then it becomes the product of max terms form. Max terms means the R term should have all the variables in the boolean expression. In this boolean expression, we have x, y and z. We can see in each R terms we missed one variable. Here in this R term we missed the z. In this R term we missed y. In this R term we missed x. All the variables should be included in each R term either in normal form or in complement form. To make this boolean expression into product of max terms, what we are going to do is we take each R terms and we are going to add the missing term in the form of product of normal and complement form of a missing variable. Now we do this process. We take first R term x dash plus y. X dash plus y equal to x dash plus y plus, here we don't have z, so we should include z. So z should be in the form of normal form, product of normal form in and complement form, that is z into z dash. Then we apply distributive law to this expression. It becomes x dash plus y plus z into x dash plus y plus z dash. Here what we did is we applied distributive law to this expression. It becomes x dash plus y plus z into x dash plus y plus z dash. Okay, now we have all the variables in the max terms. Next we take another next R term x plus z. X plus z. x plus z. In this x plus z we missed y variable, so we are going to include y variable in the form of product of normal and complement form. So we write x plus z plus y into y dash, y into y dash. Now we apply distributive law. It becomes x plus y plus z into x plus y dash plus z. In this R term also we included the missed variable y. It becomes max terms. Then we take the last R term, y plus z. Y plus z means we don't have x here, so we should include x in the form of product of normal and complement form. We write y plus z. Then we write plus. Then we write the complement and normal form of x in product term, x into x dash. Then we apply distributive law. X plus y plus z into x dash plus y plus z. Now we included all the missing variables in each R terms. It becomes product of max terms. Then the next step is we should remove the repeated item in the following expressions. So first we write the all the derived R term in the single expression. F is equal to x dash plus y plus z into x dash plus y plus z dash into x plus y plus z into x plus y dash plus z into x plus y plus z into x dash plus y plus z. Here the first term x dash plus y plus z, we are going to see whether it is repeated or not. X dash plus y z. Here x dash y plus z is repeated, so we cancel this R term, that is max term. Next x dash plus y plus, we check the next term whether it is repeated or not. The next term is x dash plus y plus z dash. We check whether it is repeated. X plus y plus z, x plus y dash plus z, x plus y plus z. This is not repeated. Then we move on to next term, x plus y plus z. We check whether this term is repeated. X plus y plus z, x plus y dash plus z, x plus y plus z. So x plus y plus z is repeated here, so we cancel this term also. Again we check the next term, x plus y dash plus z. This term is not repeated, so we cancelled all the repeated items, repeated max terms. Then we rewrite the remaining max terms. X dash plus y plus z into x dash plus y plus z dash into x plus y plus z. Next is x plus y dash plus z. The next step is we should write the binary form of each max terms. How we write is, first we should complement this max term. Then we get the binary form of this max term. When we complement this max term, we get x, y dash, z. When we complement a term, all the normal form will becomes complement form. All the operators become the complement form. Here plus is converted into AND operation. So x, y dash, z dash. The binary form of this value is 1, 0, 0. 1, 0, 0 means 4. How we can write means capital M with the suffix 4. Likewise, all the terms we should complement and write the binary form of that term. Here x dash becomes x, y plus becomes dot, y becomes y dash, plus becomes dot, z dash becomes z. The binary value of this term is 1, 0, 1. 1, 0, 1 means 5. So we write it as M5, M, capital M with suffix 5. The next is x dash, x plus y plus z becomes x dash dot y dash dot z dash. So 0, 0, 0. 0, 0, 0 means 0, M, 0. Here, when we complement this max term, it becomes x dash dot y z dash. 0, 1, 0. 0, 1, 0 means 2. So we write it as M2. We rearrange it in ascending order, M0, M2, M4 and M5. The next step is we should write this values as canonical form. Canonical form means we should write for product of max terms pi. To denote product of max terms, we should write pi. Within a bracket, we should write all the suffix values 0, 2, 4 and 5. Likewise, we should write the product of max terms. This is the method. In this method, we should convert a boolean function into product of max terms. That's all.